you. Good? Kindergarten stuff? Alright, let's try the next one. Read that one for us, Ale.
A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when its base is 7 feet?
Okay. So, do you want to draw a picture for this one to help us, or you're okay without a picture? You're okay without a picture? Or some of you need a picture? No? Just try it, just to, in case? Alright, so we know it's going to be a right triangle, right? And what's going to be constant in this triangle?
The length of the ladder.
The length of the ladder, right? The hypotenuse. That's always going to be 25. That's never going to change. So when you're working out these problems, sometimes it's important to know what's going to be constant all the time. So in this particular problem, that's going to be constant. I'm not going to put a variable for it because it's always going to be 25. Is this always going to be 7? Is the base always going to be 7? No, so I'm not going to put a 7 there right now. Is this always going to be whatever 5 or whatever? No, because it's going to be changing. It's going to be moving. Do we understand? So I'm going to use an X for this one because it's like the X-axis, and I'm going to use a Y for that one because it's like the Y-axis. Are we okay? You put variables for things that are going to change. Things that are never going to change in the problem, you can put the constant for them. Okay? Sounds good? Alright, so let's look at it. What does it say? The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So if I'm pulling the ladder away, what's changing? The distance, right, from the wall? Or can we just say the base? So the base, is the base increasing or decreasing as I pull the ladder away? It's increasing, right? So should this rate be positive or negative? Positive, right? Because the distance is, or the length of it is increasing, right? What's happening to this one? What's happening to this distance right here, this length? It's decreasing. So when I find the rate of change for that one, for the height, right, it should be at what number? It should be a negative, right? Because the height is decreasing over time. All right, cool. So let's see. What are we trying to find? How fast is the top of the ladder moving down the wall? So how fast? That means we're looking for a rate. If we're using this letter Y, then it would be the rate of change of the Y. So that would be what? dy dt is what we're looking for. What's the rate of change from the top of the ladder as it moves down? Okay, when? Well, they did use the word when in this one. When its base is 7 feet. So that means what has to equal 7? X is going to equal 7. Okay. Given, what are they giving us?
dx over dt.
dx dt equals 2 feet per second. So in this case, they're giving us the rate of change of the base, right? They're telling me as I pull it this way, it's telling me how this is changing. Okay, and what would be the equation that you think we would use here? Pythagorean theorem? Okay, so let's do it. We're going to use the letters that we have. So that'll be x squared plus y squared equals 25 squared. Why am I putting 25 at this point? Because you know that that's always going to be 25. It's not going to change. I'm not going to put a variable. Do you understand? Okay. How am I going to end up with a dy dt? What do I have to do to it? Right, we have to, you can say the word differentiate. So you can say you have to differentiate it, sir.
If I can't even think, whatever.
Okay, so find its derivative. So what would it be? 2x dx dt plus 2y dy dt equals 0. Why 0? Because it's a constant, right? The derivative of a constant is 0. You said, is it ever going to change? No, so its rate of change is 0. So 0 times that would give me 0, right? You understand? It's never gonna change, it has no rate of change, it has no derivative. Or it does have a derivative, the value is 0. Yeah? Okay, anyways. So, do we have everything we need? Do we know x? Yes. Do we know dx dt? Yes. Do we know y? Oh no. So I have two variables that I don't know, y and dy dt. Oh my god, what are we gonna do?
Give up.
Give up. Just
Use
give up.
Pythagorean theorem?
Eat oranges.
Eat oranges? So, we don't know y, but can we use what we know to find y?
Yeah.
Can we find y? We only need one y, right? We need the y specifically when x equals what? 7, right? That's the specific y we need, because there's a whole bunch of different y's that we're going to have, but we need the specific one when x is 7. So we can use Pythagorean theorem to figure that out. So now I can come down here and put a 7 here and a 25 and try to find that y. You with me? So 7 squared plus y squared equals 25 squared. Minus 7 squared. So y squared equals, what is that, 625 minus 49? Yeah? And then we need y, so we're going to square root it. So y is going to equal what? The square root of 576? Anybody know that one? 24, very good. It would actually be plus or minus 24, right? But why is it that we're only considering the positive 24? Because we can't have a negative length, right? A negative distance. So it's only 24 in this particular case. Good? All right. Oh, we forgot to put the units here. This was 7 what? 7 feet. And this is 24. Okay. So now do we have everything? Let's do it. So we're going to say 2 times what? 7 times dx dt, which is 2, plus 2 times 24 times dy dt equals 0. 7 times 2 is 14, times 2 is 28, and we got to move that 28 over, right? 2 times 24? So we got 48 dy dt equals negative 28. Divide by the 48. And dy dt is equal to, what goes into both of those numbers? 4? How many 4s into 28? And into 48? So negative 7 over 12, what units? Feet per second. And is that correct? Should it be negative? Why, Valeria? Why should it be negative? It's moving down, right? So that distance, that y, the height is decreasing. So the rate of change should be negative. Every second, that height is changing by what? Negative 7 over 12 what? Feet. So what if they asked you how long would it take for the top of the ladder to reach the ground? What would we have to know mean? We would have to know the original height, right, of the building? Okay? And then you could figure it out, right? Cool? Alright. One more example and then we'll finish. We'll be done and you can work on your homework, okay? Ready? Let's see. Montse, will you read this one to us?
The width of a rectangle is increasing at a rate of 2 centimeters per second, and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle changing when its width is 4 centimeters and its length is 5 centimeters?
Okay, so what are we trying to find? What rate is the area changing? So what do we want? What's the variable for that? dA dt. When? When the width is 4 centimeters and the length is 5 centimeters. I use a capital L just so my little L's don't look like ones. Okay? Given, what are we given? The rate of what? So the rate of change of the width and the rate of change of the length, right? So we know that dW dt is equal to what? 2 centimeters per second. Positive? Why? It says increase. How about the rate of change of the length? dL dt, is that one also increasing? At what rate? So we have everything that the problem was giving us, and what would be the equation we would use here?
Equals L times W.
We need the area of a what? Rectangle, which is length times width, okay? Now what would be the derivative of that? dA dt equals, what do we have to do for this case? Product rule, right? Okay? So the derivative of the first, dL dt times the second, plus the first times the derivative of the second. Calm down, you make it seem like it was super hard.
But I was making it easy, like I was like, yeah, DLDT and
dL dt, dW dt, we're done?
Yeah, that's what I
Remember I gave you that question on one of the tests? One of the very first tests we took before we did product rule?
What?
Before I even taught you the product rule on the previous test, I asked you, right? If I asked for the derivative of this function times this function, would it be same as the derivative of each function times each other? Right? And then we discovered that it wasn't. Right?
We all got it wrong?
No,
Because that's
some of you actually multiplied it first and then got the derivative. But then some of you did the derivative of each one and then multiplied them and you discovered that they were not the same, right? That was the whole point of that. And then the next day we did the product rule and you're like, oh, so yes.
Was one of the sides?
Cool. So, do we have everything we need? Do we know dL dt? Do we know W? Do we know L? Do we know W dt? So, can we find dA dt? Let's do it. So dA dt equals dL dt, which is 3, times what? 4 plus 5 times 2. So that gives us 12 plus 10 equals 22. So the rate of change of the area is 22 centimeters squared per second. Pretty cool? Specifically when the width is 4 and the length is 5, right? If these were different, then my answer would be different. Unless they say that it's changing at a constant rate, which we don't know. Good? Got it? You like these problems?
Yeah.
I like these. These are fun. They're going to get even more interesting, okay? So, as we go throughout the week, we're going to learn how to tackle specific types of problems, specifically shadow problems, sphere problems, cone problems, and ladder problems. Those are the 4 types that usually come out on the AP exam, so those are the ones that I'm going to focus on. But from there, you're going to gain the skills that you would need to solve any particular problem that they gave you. Today, like I said, we're doing the simple ones. Tomorrow we'll go into specific ones that require a little bit more thinking. Then the next day, the same thing, we'll tackle 2 of them. And then the next day, we'll do the last one, which is when you're looking for the rate of change of the angle. The thetas, like you told me on that ladder one, you said the theta could be changing, right? Okay, well, we're going to tackle problems where I need to do that particular type. And then that'll be it for related rates. After that, we'll have a review and a test on implicit and related rates, and that's it. So it's a small test because it's over those 2 sections. They're not a small test, but a small amount of information, right? Maybe by the end of the week, you're going to be like, oh my God, I don't know what to do depending on which problem, and you're going to go crazy, but okay, hopefully you won't. Sounds good? Taking it slow like this, seeing the different kinds. Now in the AP test, there are related rates problems, but don't think that it's like a major part of the test. If anything, maybe there'll be like 2 or 3 questions on it, okay? But it is fun, and I like teaching it because it is interesting and it makes you think. So, on your homework, you're gonna have one problem that might give you a challenge. The rest of them should not be too bad. Okay, there's one problem where there's just not one specific equation you can use to work it out. You're gonna have to use like 2 different equations. And you're gonna have to use them to find different things in order to apply it to the final problem. Okay? That one's gonna take like 2 pages to do. Okay? That one problem. But all the other 14 will be easy. Okay? Sounds good? Now these problems do require about this much space. Okay? So you do need a separate sheet of paper to work it out. And I recommend you write like the F and write down what you're finding. The when, right? The W, like skip a space, put G, and then on the side put the equation, the E, and then you can work it out there. Okay, so if you need paper, I did bring some paper out in case you didn't have any. If you do have a spiral, like I asked you to buy a spiral, you can use it.